You are tasked with securing access to a MySQL database hosted in Amazon RDS. Only authorized applications should be able to connect to the database, and you want to ensure that connections are encrypted. Options: A. Enable SSL for RDS, use IAM roles to control access, and configure security groups for network access control. B. Use AWS KMS to encrypt the database and configure an IAM policy for access control. C. Use Amazon CloudFront to secure the database and restrict access with signed URLs. D. Use AWS WAF to protect the database from unauthorized access. Correct answer: A. Enable SSL for RDS, use IAM roles to control access, and configure security groups for network access control. Explanation: Option A provides a secure solution by using SSL for encrypted communication to the database, IAM roles to manage access, and security groups to control network-level access. Why not other options? Option B: While AWS KMS can encrypt data at rest, it does not directly address secure network access or connection encryption. IAM policies are not a direct solution for controlling database access to MySQL in RDS. Option C: CloudFront is a content delivery network and not used to secure database access. Signed URLs are used for securing access to content, not databases. Option D: AWS WAF protects web applications from malicious traffic, but it doesn't address database-level access control or encryption requirements. You have a data processing application running on EC2 instances that processes large files stored in S3. The application runs periodically and requires significant computing power only during processing time. You need to reduce costs while still providing sufficient compute resources when needed. Options: A. Use Amazon EC2 spot instances to reduce costs. B. Use Amazon EC2 reserved instances for the compute capacity. C. Use AWS Lambda with S3 triggers to process files when they are uploaded. D. Use Amazon Elastic MapReduce, EMR, for processing large files. Correct answer: A. Use Amazon EC2 spot instances to reduce costs. Explanation: Option A is the most cost-effective solution. Spot instances provide unused EC2 capacity at a much lower cost, making them ideal for applications that can tolerate interruptions and run only when needed. Why not other options? Option B: Reserved instances provide cost savings for long-term usage, but are not suitable for applications that only require compute power periodically. Option C: AWS Lambda is a good choice for serverless applications, but it might not be the best fit for processing large files, especially if the processing requires significant compute power or longer execution times. Option D: EMR is ideal for big data processing, but may introduce additional complexity and cost compared to spot instances for simple file processing tasks. Your company's web application is running on EC2 instances in a single availability zone. You need to implement high availability for the web application, ensuring that it remains operational even if an availability zone goes down. Options: A. Use an elastic load balancer, ELB, with EC2 instances in multiple availability zones. B. Use EC2 auto-scaling with instances in a single availability zone and ELB for traffic distribution. C. Use Amazon Route 53 with health checks to direct traffic to another region in the event of failure. D. Use AWS Global Accelerator to route traffic to the nearest available region and deploy EC2 instances in multiple regions. Correct answer: A. Use an elastic load balancer, ELB, with EC2 instances in multiple availability zones. Explanation: Option A ensures high availability by distributing EC2 instances across multiple availability zones and using an elastic load balancer, ELB, to balance the traffic between them. Why not other options? Option B: While EC2 auto-scaling helps with scaling, deploying instances in only one availability zone does not provide high availability. Option C: Route 53 health checks can help with failover to a different region, but it's more complex and may result in higher latency compared to using multiple availability zones within the same region. Option D: AWS Global Accelerator routes traffic to the closest available region, but using it for a simple web application with high availability needs within a region adds unnecessary complexity. You have a web application running on EC2 instances in an auto-scaling group. The scaling policies need to be based on custom application-level metrics, e.g. request count per second, instead of just CPU utilization. You want to implement this efficiently. Options: A. Use Amazon CloudWatch to create custom metrics for the application and set up auto-scaling policies based on those metrics. B. Use AWS X-Ray to track application performance and automatically scale EC2 instances. C. Use Amazon EC2 auto-scaling with scheduled scaling based on application usage patterns. D. Use AWS Lambda to automatically adjust the number of EC2 instances based on custom metrics. Correct answer: A. Use Amazon CloudWatch to create custom metrics for the application and set up auto-scaling policies based on those metrics. Explanation: Option A allows you to create custom CloudWatch metrics, which can be used as the basis for auto-scaling policies. This provides the most flexible and scalable solution for application-specific scaling. Why not other options? Option B. AWS X-Ray is useful for tracing application requests and performance, but it doesn't directly integrate with auto-scaling for adjusting instance counts based on custom metrics. Option C. Scheduled scaling is based on time and usage patterns but doesn't dynamically respond to real-time metrics like request count per second. Option D. AWS Lambda can automate many tasks but isn't designed to directly adjust the size of an auto-scaling group based on application metrics. CloudWatch provides a more integrated solution. You need to secure access from an EC2 instance to an S3 bucket. The instance should only be able to access the bucket and no other AWS resources, and you want to ensure that access is done using the most secure method. Options: A. Attach an IAM role to the EC2 instance that grants access to the S3 bucket. B. Use a security group to control access from the EC2 instance to the S3 bucket. C. Use an IAM user with access keys stored on the EC2 instance for S3 access. D. Use AWS KMS to grant the EC2 instance access to the S3 bucket using encryption. Correct answer: A. Attach an IAM role to the EC2 instance that grants access to the S3 bucket. Explanation: Option A is the most secure and recommended approach. Attaching an IAM role to the EC2 instance allows for fine-grained access control using policies, and the instance can securely access the S3 bucket without the need for credentials being stored on the instance. Why not other options? Option B. Security groups control network access, but don't provide access control for AWS resources like S3. Option C. Storing IAM user credentials on the EC2 instance is not a recommended practice. IAM roles provide a more secure and scalable approach. Option D. AWS KMS is used for encrypting data, but is not designed to provide access control for an EC2 instance to an S3 bucket. IAM roles are the correct way to manage access permissions. You need to deploy a scalable web application that provides low-latency responses to users in multiple regions worldwide. The application should be able to scale automatically based on demand and provide fast content delivery to users globally. Options: A. Use Amazon CloudFront with S3 for content delivery and EC2 auto-scaling to handle application load. B. Use Amazon Route 53 with health checks to route users to the nearest region, and deploy EC2 instances in multiple regions. C. Use Amazon Elastic Load Balancer, ELB, with instances in a single region and enable cross-region replication for data storage. D. Use AWS Global Accelerator to route users to the closest region, and use EC2 instances in a single region. Correct answer: A. Use Amazon CloudFront with S3 for content delivery and EC2 auto-scaling to handle application load. Explanation: Option A optimizes content delivery using CloudFront, a global content delivery network, CDN, while EC2 auto-scaling ensures the application scales based on demand. S3 can store static content for fast access. Why not other options? Option B. Route 53 with health checks can help with routing traffic based on regional health but does not provide a full content delivery and scaling solution like CloudFront and auto-scaling. Option C, ELB in one region is not ideal for handling global traffic. Cross-region replication of data adds complexity and increases latency. Option D, Global Accelerator routes traffic but does not manage content delivery or automatically scale application load in the region itself. Your company needs a cost-effective solution for backing up large amounts of data generated by a web application. The backup solution should be durable, scalable, and easily accessible for recovery in case of failure. However, you want to minimize costs for storing data that is not frequently accessed. Options: A. Use Amazon S3 Glacier for long-term data storage and S3 lifecycle policies to transition infrequently accessed data to Glacier. B. Use Amazon EBS snapshots to back up data and store them in a standard S3 bucket. C. Use AWS Backup to create backup plans for data stored in RDS and EBS. D. Use EC2 instances with manual backup scripts to copy data to S3 on a schedule. Correct answer: A. Use Amazon S3 Glacier for long-term data storage and S3 lifecycle policies to transition infrequently accessed data to Glacier. Explanation: Option A offers a cost-effective solution for long-term, infrequent data access by using S3 Glacier for cold storage and automating the data transition with S3 lifecycle policies. This reduces costs for storing backups. Why not other options? Option B, EBS snapshots are good for EC2 volumes, but not designed for cost-effective long-term backup solutions. Standard S3 storage is more expensive than Glacier for infrequently accessed data. Option C, AWS Backup provides backup for managed services like RDS and EBS, but is not as cost-efficient for large amounts of data, especially when compared to Glacier. Option D, manual EC2 backups require extra management and are not as automated or cost-effective as using Glacier for long-term storage. Your team needs to implement a CI/CD pipeline for deploying code changes to an application hosted on EC2 instances. The pipeline should automate the build, test, and deployment process, and you want it to be fully integrated with AWS services. Options: A. Use AWS Code Pipeline, AWS Code Build, and AWS Code Deploy to automate the CI/CD process. B. Use AWS Lambda with S3 for versioning code, and deploy using EC2 auto-scaling. C. Use AWS CloudFormation to automate deployments, combined with S3 for storage of the application code. D. Use Amazon EC2 instances with Jenkins and integrate with GitHub for version control. Correct answer: A. Use AWS Code Pipeline, AWS Code Build, and AWS Code Deploy to automate the CI/CD process. Explanation: Option A is the best solution for CI/CD. AWS Code Pipeline automates the entire pipeline, while Code Build handles the build process, and Code Deploy manages the deployment of the application to EC2 instances. Why not other options? Option B, AWS Lambda and S3 are not ideal for managing a CI/CD pipeline, especially for build and deployment stages. Lambda works for serverless applications, but lacks CI/CD integration. Option C, CloudFormation automates infrastructure provisioning but is not designed specifically for CI/CD workflows. S3 is used for storage, but not for deployment automation. Option D, Jenkins is a third-party solution that requires manual setup and management, while AWS native services like Code Pipeline provide a more integrated, fully managed solution. Your company wants to migrate an on-premises MySQL database to AWS with minimal downtime. The migration should ensure that the database is fully synchronized between the on-premises system and AWS during the migration process. Options: A. Use AWS Database Migration Service, DMS, to replicate the database from on-premises to RDS MySQL with minimal downtime. B. Perform a manual export of the MySQL database to S3 and import it into Amazon RDS-C. Use AWS Snowball to transfer the MySQL database to Amazon S3, and then import it into RDS-D. Use Amazon Aurora with MySQL compatibility and manually copy the data to Aurora. Correct answer, A. Use AWS Database Migration Service, DMS, to replicate the database from on-premises to RDS MySQL with minimal downtime. Explanation: Option A is the ideal solution. AWS DMS allows for continuous data replication from an on-premises MySQL database to Amazon RDS MySQL with minimal downtime, making it perfect for live migrations. Why not other options? Option B, manually exporting and importing the database is error-prone and will cause significant downtime during the process, making it unsuitable for a live migration. Option C, AWS Snowball is used for large data transfers but is not suitable for real-time data replication, which is necessary for minimal downtime migrations. Option D, Aurora is compatible with MySQL but doesn't provide an automatic mechanism for migrating an on-premises MySQL database with minimal downtime. DMS is better suited for this purpose. Your company is deploying a web application in AWS. The application needs to be hosted in a private subnet for security reasons, but it also needs to interact with services like RDS and S3. You want to ensure that only the web application can access these services, while external access is restricted. Options: A. Use a VPC with private and public subnets, place the web application in the private subnet, and use VPC endpoints for secure access to S3 and RDS. B. Place the web application in a public subnet with a security group that restricts traffic to S3 and RDS. C. Use a direct connect connection from on-premises to AWS for secure access to S3 and RDS. D. Place the web application in an auto-scaling group in a public subnet and use security groups to control access. Correct answer, A. Use a VPC with private and public subnets, place the web application in the private subnet, and use VPC endpoints for secure access to S3 and RDS. Explanation: Option A provides a secure and scalable architecture. The web application is hosted in a private subnet, ensuring it is not directly accessible from the internet, while VPC endpoints allow secure access to S3 and RDS without needing a NAT gateway or public IP addresses. Why not other options? Option B, placing the web application in a public subnet exposes it to the internet. This goes against the requirement of keeping the application secure in a private subnet. Option C, AWS Direct Connect is used for private connectivity between on-premises and AWS. It is unnecessary for accessing services like S3 and RDS within the AWS cloud. Option D, hosting the application in a public subnet with an auto-scaling group exposes it to external traffic, making it less secure.